You're welcome to Friendly Maths page. In today's lesson, I'm going to discuss with you the Pythagoras theorem and how to use it to solve questions. Stay tuned and focus as we go through the scope of this lesson. I'm very sure you'll achieve the goal that you're expecting. Let's move on. Now, the Pythagoras theorem, what is it about? What are we going to talk about? Now, the Pythagoras theorem is actually centered on right angled triangles. Now, this is a right angled triangle. This is a right angled triangle. Right angled triangles have one of their interior angles equal to 90 degrees. So whenever you get a triangle whereby one of its interior angles is 90 degrees, then that triangle is a right angled triangle. So this is a right angled triangle. Now let's see the parts of a right angled triangle. So let me call this side A. Let me call here side B, and that of here to be side C. Now this side C is called a hypotenuse. So you can call this side the hypotenuse. And these two sides are called the legs of the triangle. So these are the legs of the right angle triangle. Even though they have specific names, sometimes you can call this side the opposite, and that of here the adjacent, depending on the interior angle that we will talk about here. So for now, let's take this side to be the two other sides of the triangle. So what's the Pythagoras theorem? That is what we're going to deduce right now. The Pythagoras theorem states that the square of the hypotenuse, the side which faces the 90 degrees, that is the C. So the square of the hypotenuse, that is C square, is equal to the sum of the squares of the two other sides. The sum of the squares of the two other sides. So this is one of the other sides that we are talking about. So that's going to be A squared plus B squared. So that's the sum of the square of the two other sides. So when you add these two guys to that of this, that will give you the square root of the hypotenuse. So that's the Pythagoras theorem. Okay, so now that we know the Pythagoras theorem, let's use it to solve this question. How do we use the Pythagoras theorem to find the length of BC? BC is the hypotenuse, and that is the side that faces the 90 degrees. Remember that the hypotenuse always faces the 90 degrees. And according to the Pythagoras theorem, the square of the hypotenuse, so in this case, the hypotenuse is BC. So let me work it here. So the hypotenuse is BC. So the square of this, that is BC squared, is equal to the sum of the squares of the two other sides. These are the two other sides, AB and that of AC. So that's going to be the square of AC plus the square of AB. So that's the Pythagoras theorem. So we just have to do substitutions here to find the side BC. So we have BC squared is equal to AC, that is 6 centimeters. I can just write 6. So we have 6 squared plus this one is going to be 8 squared. So we have BC squared equal to 36 plus 64. The square of 8 is 64 and that of 6 is 36. So BC squared is equal to 36 plus 64 and making 100. So we have 100. How do we find BC? We have BC squared. So we just have to, find the roots on both sides. So I'm going to get a big root of BC squared equal to the root of 100. So whatever you do here, you have to do the same thing here. So the square root, the square sign or the square will be able to cancel the root sign here. So we have BC, that is what we are looking for, equal to the root of 100. 100 is a perfect square. So 10 times 10 will give you 100. So that means the root of 100 is 10. So that's going to be 10 centimeters. Let's take our next question. And this is an interesting diagram. Let's see how we can find the value of x or work out the value of x. This is a Pythagoras, this is a right angle triangle that we can use the Pythagoras theorem to, find the value of x here. First of all, we have to look for the hypotenuse. And this is a hypotenuse. Remember, it always faces the 90 degrees. So let me state the Pythagoras theorem and use it to solve or find the value of x. The square of the hypotenuse. The hypotenuse is this. We have x plus 2 squared. This is a binomial, so you have to put in bracket. It's equal to the sum of the squares of the two other sides. And these are the two other sides. So that is how you're supposed to set up the equation. This is the Pythagoras theorem. So the next thing is to expand these expressions. And how do we expand this? This is a perfect square. We have to multiply this one by itself. So that's going to be x plus 2 multiplying x plus 2. And it's equal to, the same thing applies to this, x minus 2 multiplying x minus 2. Plus a squared is going to be 64. And we have to multiply these two binomials. We can use the distributive property, or you can decide to FOIL it, and you get your answer. So let's do that. Let me use the distributive property. So x times x will give me x squared. X times 2 will give me 2x. And 2 times x will give me 2x. 2 times 2 will give me 4. And that is equal to, the same thing applies to this. We have to use the distributive property. So x times x will give me x squared. X times negative 2 will give me negative 2x. Negative 2 times x will give me negative 2x. And negative 2 times negative 2 will give me positive 4 plus 64. The next thing is to, simplify. So you have x squared here. These two guys, they are like terms. We can simplify to get 4x plus 4 equal to x squared. These two guys are also like terms that we can simplify to get, negative 2x minus 2x will give us negative 4x, and 4 plus 64 will give me 68. So what do we do next? We have to group the letters on one side and the numbers on one side. So I'm going to group all the letters on the left hand side, this side, and I'll bring the numbers to this side. So I have to take x squared to this side, and that's going to be x squared minus s squared. So I've taken this one to this side. Now we have plus 4x. We have to take negative 4x to this side, and that's going to be plus 4x. So we are going to reverse the sign after bringing it to this side. So we're going to get 68, and I have to take 4 to this side too. It's going to be minus 4. So s squared minus s squared will give me 0. 4x plus 4s will give me 8x equal to 68 minus 4 will give you 64. So I just have to divide here by 8, here too by 8, and 8 can cancel 8. 8 can go into 64 8 times. So x is equal to 8. That is how we can find the value of x. Let's take our next question. That is our next question. We have to find the value of x. Let's see this diagram. Another right angle triangle. And this is the hypotenuse. That's the side facing the 90 degrees. So that's the hypotenuse. So without wasting much time, let's work this question quickly here. So let me state the Pythagoras theorem here. The Pythagoras theorem states that the square of the hypotenuse, that's going to be qr squared. So we have qr, that's the hypotenuse. is equal to the sum of the squares of the two other sides. So these are the two other sides. So we're going to get PQ squared plus PR squared. So the next thing is to do substitutions. QR from the diagram is that going to be 15 meters. So you can just write 15 for now. So that's 15 squared equal to PQ. PQ from the diagram is 12. So we have 12 squared. And out of PR is X. So we have X squared. So 15 squared is going to be 225. That is 15 times 15 equal to 12 squared, which is 12 times 12 will give us 144 plus S squared. So what are we going to do? We're going to find the value of X. So we've got to bring 144 to the other side. So this side, we're going to get 225 minus 144. That will be equal to S squared. So you have to subtract, 144 from 225. And that will give me this. That will give me 81. So we have 81 equal to X squared. Remember, we want to find X, not S squared. So I have to introduce the square roots on both sides to do away with this guy. So let's do that. The root of 81 will give me 9 equal to, so this square will cancel the square root. So we have X left. Remember, the unit is meters. So that means X is equal to 9 meters. Quickly or easily, we have been able to solve this question. Let's take the next one. In a triangle ABC below, AB is equal to BC. So AB and BC, they are the same. And that is 13 centimeters. AC is equal to 10 centimeters. That is from this point to this point is 10 centimeters. We have to find BD, from this point to this point. How do we go about this triangle? So we can see two triangles, two right angle triangles making up this isosceles triangle. In fact, it's an isosceles triangle because two sides are the same. So this side is equal to this side. So that is an isosceles triangle. So take notice of that. And this side, which is BD, that's the height, has divided the triangle into two equal parts. That is something that you're supposed to know about isosceles triangle. The side or this height, divides the triangle into two parts. And because of that, AD and DC are going to be the same. Remember, AC is 10 centimeters. So that means the side is actually equal to this side. So here is going to be 5 centimeters. And here too is going to be 5 centimeters. So that is how you have to know this. Now let's see something. We can set up this triangle. We can separate the two triangles so that you can see it clearly. Let's see something. So when you separate the two triangles, this is what you're going to get. So here's going to be the side A. This is D. And here's going to be B for the first part. Here we have D, we have B, and we have C here. The side is 13. And here too is 13. Here is going to be 5. Here too is 5 centimeters. So you see, they are just identical triangles. They are actually the same. So when you take this triangle, when you take BDC, you can use it to find your BD. And when you take ABD, you can also use it to find your side BD. So any of them that you want to use, you can use here. So let's see. I'm going to use, ABD to find BD. So let me see how I'm going to do it. So always you have to identify the hypotenuse. This is the hypotenuse and it faces the 90 degrees. So the hypotenuse in this case is going to be AB. So we have AB squared. That is equal to the sum of the squares of the two other sides. So we have AD squared plus BD squared. So let's do the substitution. AB is going to be 13. So we have 13 squared equal to AD, that is 5 squared, plus BD, that is what we are looking for. So 13 squared is going to be 169 equal to 25 plus BD squared. So I have to take 25 to the side. So we have 169 minus 25 equal to BD squared. And that will give me 144 equal to BD squared. So I have to find the root on both sides. So the root here and then the root here. The root of 144 will give me 12. So you have 12 equal to BD. Remember, the square will cancel the square root. So that means BD is equal to 12 centimeters. So let's take our last part one diagram, and that is going to be a trapezium. The diagram is a trapezium ABCD. AB is equal to 9 centimeters. BC is equal to 4 centimeters. CD is equal to 6 centimeters. And we have to calculate the perimeter of the trapezium. So that's a trapezium for you. The perimeter of a shape is the total distance around the shape. So when you take this particular trapezium, the perimeter of it is going to be, AB plus BC plus CD, and plus AD or plus DA. But as we speak, we have only 3 sides. We have to get the 4th side so that we can find the trapezium, the perimeter of the trapezium. So how do we find the perimeter of this shape? Because we have to find AD. Now, how do we get the AD? How can we find the length AD for us to find the perimeter? The best thing is to, draw a fifth line. This is how the line is going to be. So let me use this one. So when you introduce, the fifth side, that is the broken lines, you see that the shape is a triangle, and not just a triangle. It is a right angle triangle. This is a 90 degrees angle, and it is forming a right angle triangle. So let's use, let's say A for this point. So we have triangle ADE, and ADE is a right angle triangle. Now, how do we find AD? That is what we want to find. We have to get this side and that of this side. You know that this side is equal to this side because that is a rectangle, and opposite sides are equal. So that means here is equal to 4 centimeters. We have to also get AE. Now we can get AE from this. AB is equal to 9 centimeters from the question, and CD is just 6 centimeters. So if I want to get AE, I have to subtract 6 centimeters from 9 centimeters, and that will give me, 3 centimeters. So here's going to be 3 centimeters. Okay, so that means that from the right angle triangle, we can find the side AD. And let's see, AD is the hypotenuse. Have you realized that? AD is the hypotenuse because it faces the 90 degrees. So let's work it here. Now we can find the value of AD. So I can say that from triangle ADE, AD AD squared, that is the hypotenuse squared, is equal to the sum of the squares of the two other sides. So these are going to be the two other sides, AE, side AE squared plus ED squared, or DE squared. They are all the same. So we have to do substitutions. We don't know AD, that is what we want to find. So it's still going to be that. And AE from the question now, it is 3 centimeters. That is this one. So we have 3 centimeters. So we have 3 squared plus ED is going to be 4 centimeters. So 4 squared. So you have AD squared equal to 9 plus 16. So AD squared is equal to 25. 9 plus 16 is equal to 25. So you have to find the roots on both sides, and we're going to get AD equal to the root of 25. So AD is equal to 5 centimeters. So that's the value of AD. So how do we find the perimeter? That is very, very easy. So this implies that the perimeter is equal to AB plus BC plus CD and plus AD or DA. They are all the same. So the perimeter is equal to AB, that is 9 centimeters, plus BC, 4 centimeters, plus CD, 6 centimeters, and plus AD, which is now 5 centimeters. So the perimeter, 6 plus, 4 is going to give us 10. And 10 plus 9 will give us 19. 19 plus 5 will give us 24. So we have 24 centimeters. So that's the perimeter of the trapezium. Let's take our last question. So that will be our last question for today. The diagram shows a quadrilateral ABCD. We have to find the side AB, CD. Where is CD? This is CD in the area of ABCD. Let's get it started. How do we go about this? This is how somehow, a complicated shape, but it's just simple. Just combination of two right angle triangles, and we've gotten this quadrilateral. This is actually a trapezium. Now let's do it. Let's take it one after the other. So let's solve the eye. And we have to find AB. The side AB is from the triangle ABC. So let me write this one. From triangle ABC. Now, when you take the triangle ABC, this is the 90 degrees symbol, and this side is facing the 90 degrees. So that means the side, which is AC, is the hypotenuse. So I can say that, AC squared is equal to the sum of the squares of the two other sides. So we have AB squared plus BC squared. So let's do substitution direct here. AC is 5, so that's going to be 5 squared equal to AB. That is what we are looking for. So AB squared plus BC. BC is 3 centimeters, so that's going to be 3 squared 5 squared is 25 equal to AB squared. And 3 squared is 9. That is 3 times 3. So what do we do next? We have to bring, 9 to this side, or we subtract 9 from both sides. So that's going to be 25 minus 9 equal to AB squared. 25 minus 9 will give us 16. So 16 is equal to AB squared. Now we want AB, not AB squared. So we have to find the root of, both sides so that we can do away with the square. So this guy will cancel this one. And the root of 16 is going to be 4. 16 is a perfect square. So 4 times 4 will give you 16. So that means 4 centimeters is equal to the line AB. So that is how we can find AB. Let's move on to the next one. Let's find CD. Okay, so let's go ahead and find the side CD. You can also work it. You can pause the video and work it. No, CD is from, triangle ACD. So let me just say from triangle ACD, you can decide to call triangle ADC. Okay, so what's the hypotenuse? A very tricky diagram. This is 90 degrees, right? And this side is facing the 90 degrees. So that means the hypotenuse is AD. So we can say that AD squared is equal to the sum of the squares of the two other sides. And what are the other sides? The other sides are AC. So we have AC squared plus, CD squared. Now we just do substitutions. AD is 13. So you have 13 squared is equal to AC, that is 5 squared, plus CD, that is actually what we are looking for. So 13 squared is going to be 169. That is equal to 5 squared is 25 plus CD squared. Subtract 25 from both sides, or simply we take 25 to the side. So we're going to get 169 minus 25, and that is equal to, CD squared. So 169 minus 25 will give us, 144. That is equal to CD squared. We have to find the roots on both sides so that we can get our CD. So we have, so you know that the square can cancel this one. So we have CD equal to the root of 144. And since 144 is a perfect square, we can easily get 12 as the answer to that. So CD is 12 centimeters. So that is how we can also find, the side CD. Let's come to the area of triangle ABCD. So how do we find the area? Okay, so if you want to find the area of the triangle of, ABCD, we have to know the areas for the two triangles. So we find the area of the triangle ABC and that of triangle ACD, and then we just add them together to find our area of the triangle ABCD. Or we can use a different approach. This is a trapezium, so we can use the formula for finding the area of a trapezium and we can get the same answer. But I want to use it, the triangle approach. So I'm going to find the area of triangle ABC. So let me work that one here. So area of ABC. And the area of a triangle has a formula: A equal to half times base times height. So when you get to this triangle, what will be the height, what will be the base? You should know as a mathematician that always base and height, they form 90 degrees. So we just work this one to get 4 centimeters here. So one of them will be the height, one of them will be the base. So you can take AB to be the base and BC will be the height, or AB will be the height and BC will be the base. It doesn't matter. So that means I'm going to get, I'm going to get area equal to half times, 4 times 3. So area is equal to so 2 can cancel itself. 1 goes into 4 2 times. So A is equal to 6 centimeters squared. So that's the area of the triangle ABC. Let's find the area of triangle ACD. So we have the area of ACD. So the same approach, because ACD is also a triangle. So we can just say that the area of a triangle is equal to half, times the base times the height. So let's track that triangle and see the base and the height. So like I said, the base and the height will always form 90 degrees. So that's going to be this side AC and that of CD. And we just got CD to be, 12 centimeters. So that will be the base and the height. So let's do the substitution here. So we're going to get 1 over 2 times 12 times 5. So simply, we can just do cancellations here. So 2 goes into itself 1 time. It goes into 12, 6 times. So that means that we have 6 times 5 as the area. So area of the triangle ACD is equal to 30 centimeters squared. Now we have to find the total area. And that's very, very simple. So the total area is equal to area of ACD plus area of ABC. And that's going to be 30 plus, the previous one was 6. So we have 36 centimeters squared. So that's the area of ABCD. Thank you for watching.